welcome to the Azure Orbital session today. My name is Ashish Jain and I lead the product management efforts for Azure Orbital, which is a new cloud-based ground station as a service we have been working on. Today, we will introduce Azure Orbital to you and show you how easy it is to use Orbital to communicate to your satellites. With the recent innovations that have happened in the industry, the cost of launching satellites in space has come down significantly. 5 years back, this cost used to be about 50,000 US dollars to send 1 kilograms in space. The cost has now come down 20x to about 2 to 3,000 US dollars per kilograms. With this, more satellites are now being launched, and it is estimated that more than 25,000 satellites will be launched in next 3 to 5 years alone. As satellite operators send more satellites to space, they need more ground stations to communicate to their satellites. Building your own ground stations is often very expensive and it requires capital expenditures. Other options for satellite operators are that they rent or lease a ground station, which often locks them down in long-term contracts, which again makes it very expensive for them. In addition, as more data comes down from space, more compute and more resources are required to process and store this data. For the same, satellite operators have already started leveraging cloud, which needs the data from space to be backhauled to the cloud. All of this put together makes a great case for a cloud-based ground station as a service. We are happy to introduce Azure Orbital to you today. Azure Orbital is a fully managed cloud-based ground station as a service that enables you to communicate to your satellites, downlink or uplink data, and process it and thereby scale your operations. With Azure Orbital, we deploy satellite ground stations in our data centers, enabling a variety of scenarios for our customers ranging from Earth observation to even global satellite communications. Spanning across a variety of industry segments from remote sensing, defense, intelligence, oil and gas, maritime, and several other industry segments. Our approach with Azure Orbital has been partner-led. Our goal has been to build a vibrant ecosystem of partners to jointly create more value both for our partners as well as our customers. In addition to building our own ground stations, we have partnered with KSAT, Viasat Real-Time Earth Platform, and US Electrodynamics to enable our customers to use these partner ground stations to downlink and process data in Azure. We have partnered with Kratos and Emergent to bring their software processing capabilities in the cloud as part of our Orbital platform. Our partnership with SCS also enables them to build and sell managed services using Orbital to their customers. Qubos is also in the process of bringing their mission control capabilities to Azure Marketplace for customers to use alongside with Azure Orbital. Azure Orbital enables multiple use cases for our customers ranging from Earth observation to global communications. For the purposes of Earth observation, satellite operators can use Azure Orbital to schedule contacts with their satellites on a pay-as-you-go basis and directly ingest data from the satellites into the cloud using Orbital ground stations. They can then process this radio signal in the cloud using integrated cloud software modems or use other certified modems with Azure Marketplace for unique mission needs. We will bring other data processing capabilities like image processing and calibration on Azure Marketplace from our partners that will seamlessly integrate with Azure Orbital. Satellite providers who provide global communication capabilities to their customers would be able to use Azure Orbital to either co-locate new ground stations in our data centers or edge of our network, or even interconnect their existing ground stations with our global Azure backbone. They can then route their traffic on the global Microsoft network, leverage internet breakout from the edge of our network for providing internet services and other managed services to their customers. Ground station or teleport providers can also partner with Azure Orbital to digitally transform, or if you will, virtualize their ground stations. By doing so, customers can use these ground stations to schedule their contacts with their satellites while leveraging all the software, radio processing, and data processing capabilities offered by the platform and also Orbital partners through Azure Marketplace. Now let's take a look at Azure Orbital for Earth observation scenario in more detail. It is very easy to schedule contacts with your satellites using Azure Orbital. It is a simple three-step process which begins by onboarding your satellite on Azure Orbital. This can be done by creating a spacecraft resource by providing the two-line elements or NORAD IDs for your satellites directly in Azure portal or even by using Orbital SDK and APIs. Thereafter, you can create a contact profile which is then used by the platform to communicate with the satellite. Now, this contact profile contains configuration parameters like frequency bands to use, how much bandwidth is the signal, what is the polarization of the radio wave, and other similar information. The profile can also be created in Azure Orbital by leveraging Orbital SDKs or APIs. Once a satellite is onboarded and a contact profile is created, customers can then use Orbital platform to schedule contacts with their satellites and communicate with them at the time of the contact. The Orbital platform shows you available contact opportunities with your satellite by making orbit calculations to identify time slots available for your satellite and hence schedule the contact based on these available options. Let's now take a look at the high-level architecture to get a deeper look into the Azure Orbital platform. On the left side is the ground station deployed in our data center. The box in the center, you can think of it as the Orbital platform virtual network, which provides the data to the customer's virtual network on the right side. Now, just before the time of the contact, the Orbital platform orchestrates all components and configures them based on the contact profile. At the time of contact, all components and data pipeline is ready and enables the customers to communicate with their satellite from their virtual network during the period of the contact. The antenna is controlled by the platform to track your satellites at the time of the contact, and through a digitizer hardware deployed at the ground station, digitizes the radio frequency from analog to digital format streamed to the cloud as UDP traffic containing radio signal in the well-known Vita 49 formatted data. This digitized radio signal is then delivered to the endpoint in your virtual network, in the customer's virtual network, based on the customer's contact profile. Now, customers at this point have multiple options. Customers can say, hey, Orbital, can you please demodulate and decode the radio signal before delivering me the data? In which case, the Orbital platform uses the integrated software modems to process the radio. Customers can also choose to say, hey, Orbital, I have a unique mission, so I need to be able to control and manage the software modem more closely. In this case, the customers can deploy a cloud modem from our partners, Kratos and Emergent, in their virtual network directly from Azure Marketplace. Customers can also work with our partners, again Kratos and Emergent, to have a custom modem built and deployed for their unique mission needs. We have partnered with them to onboard them as Azure Orbital managed service providers to enable you to use unique mission needs with Azure Orbital. Customers also have an option to bring their own modems in their virtual networks deployed as IaaS compute on Azure. Orbital also delivers full or raw wideband digitized radio signal to customers' virtual network. Just for perspective, raw IQ data for a full 450 to 500 megahertz radio signal can constitute a data stream of more than 10 Gbps delivered to the customer's virtual network in real time. We have partnered with our cloud modem partners, both Emergent and Kratos, to leverage Azure platform accelerations to be able to process huge amounts of data in real time in a highly reliable and scalable manner. Once data is delivered to the endpoint in customer's virtual network, customers can then use other Azure services like AI or ML or even Azure Cognitive Services for that matter to process the downlink data and perhaps store in Azure storage as well. Customers can also bring their own TT&C workloads for tracking telemetry and control purposes and deploy them on Azure in their virtual network to enable it to communicate with their satellites during the contact period. Major Tom from Qubos and several other mission control workloads are going to be available on Azure Marketplace very soon for you to use with Azure Orbital. Here is our roadmap to building several ground stations globally. We start with our first ground station in the state of Washington in US, followed by other geographies, most of which are already work in progress. Each ground station is deployed either in our data center premises or close to the network edge if outside our data centers. Each ground station site will have at least two 6.1 meter antennas, which will support X, S, and UHF bands with auto tracking capabilities. We are happy to share that our partnership with KSAT will enable a deep global integrated backhaul to Azure from KSAT ground stations. Customer will be able to use the Orbital platform to schedule contacts on these ground stations and bring data to Azure for processing and storage using deeply integrated interconnect of these ground stations with Azure Orbital. In addition to KSAT, we have partnered with Viasat Real-Time Earth Platform and US Electrodynamics to integrate their ground stations with Azure Orbital. This enables our customers to communicate to their satellites by using these partner ground stations and ingest data directly in Azure. Together, we believe this will offer the widest coverage and flexibility possible for our customers to communicate with their satellites with highest agility and reliability. Now let's take a look at Azure Orbital in action. In this demo, you will see Azure Orbital scheduling a contact with partner ground station to communicate with a NASA satellite called Aqua, downlink the data, digitize it using Kratos SpectralNet digitizer deployed at the ground station, transport it to the cloud using Kratos Data Defender, and demodulate and decode the digitized radio signal using Kratos Quantum RX, a high-speed software modem optimized specifically for Azure in the cloud. We then process this decoded data using NASA tools in real time to generate the final image from the satellite. I will now hand over the stage to Rishi from my team to give you a walkthrough of the demo. Rishi, over to you.
In today's demo, we'll be doing a real-time pass with the NASA Aqua satellite and show you the portal as well as the pass in real time. We'll be skipping ahead certain parts just to save time in this demo. You can land at the Azure Orbital homepage and you'll find multiple options to onboard a spacecraft, create a contact profile, or schedule contacts. In today's demo, we've already created the contact profile and onboarded Aqua as a spacecraft. Clicking on the contact profile, you can see the properties that go with it, such as minimum elevation, auto track, and minimum viable contact. Clicking on spacecrafts, you can look at the properties associated with your spacecrafts. In this case, Aqua, which has the NORAD ID of 27424, those TLEs that go with it, and it's authorized on the system, which means we're good to go and schedule this contact. You can see the upcoming contacts that are scheduled for this spacecraft, which in this case are none. So let's go ahead and schedule one. So click on Schedule Contact to proceed. You get to choose the contact profile you want with this spacecraft, the ground station region, the start time, and the end times. Clicking search will generate the query against our system where we'll use the TLEs, as you've seen in the last pane, to come up with the opportunities for you to select. And over here, we'll go with the 15-degree pass that is going to come upon us right here in a couple of moments. We click schedule. It's going to schedule it, and then upon scheduling, it will take us to back to the Aqua spacecraft page, and clicking on contacts, we can see that our contact is indeed reserved and scheduled. So we're good to go and jump right into this upcoming pass. Here we can see a live webcam view of the 7.6 meter dish housed at US Electrodynamics Incorporated, headquartered in Brewster, Washington. On the right side are the web panes for all the components that are in the RF architecture chain. So we'll start off with the wideband digitizer, whose responsibility is to digitize the incoming X-band spectrum, slice it up into samples, and then forward that on to the data defender, which is in the physical location at USCI. We've instantiated a data defender in the cloud. And then also in the cloud as well in Azure, we've instantiated a software modem that will be doing the demodulation in real time. We've also set up some scripts in the background to work on that data and provide files in real time. So we see the satellite is above the minimum elevation. We see the signals there. The output is turned on. And we can see the data being propagated through the data defender at the physical location at USCI Brewster. We see that the data defender in the Azure cloud is also getting the data from the physical location over WAN. And through the networking accelerated DPDK Azure Fabric, it's being provided to the Quantum RX software modem in the cloud. Here, this is doing demodulation in real time. So all of this is happening in real time. The FFT is looking really good. The IQ plot's looking really tight. The carrier lock is locked. The EBNO is looking on par in performance for a 7.6 meter dish. We're decoding and demodulating the NASA signal, which is OQPSK. We see the bytes coming in over the UDP interface from the Defender. The frame sync is a CCSDS sync marker, and we can look at the status and see everything's in lock. So everything is looking really good right here. The pass is being executed, and everything is looking on par. So this pass will continue on for another 7 minutes. So we're just going to skip ahead towards the end, where we'll show you the file is being generated and pull one of the images out from the science data of NASA Aqua. Okay, we're at the end of the pass. The antenna is at the other position in the sky. The signal output from the spectrum analyzer has been stopped. We see that the NASA tools have put in these HDF files in this Azure storage account. We're going to download it and open up the HDF viewer software, which allows us to inspect the HDF file elements. We just saw these satellite dish go back to its stowed position. These files are output from the RTSPS and IPOP tools that are available for everyone to use from the NASA DRL website. What we're going to do now is we're going to pull the image out of this HDF file set. There is some manual tweaking parameters required to display the image because it is just raw pixel data of the sensor. The key takeaway here is that you can put your own processing software here, your own image processing, radar processing, RF spectrum monitoring processing here, whatever the satellite data is being provided, and we will provide the ground station solution, our partner ground stations, and provide a virtualized RF stream right into the cloud where you can instantiate the modems that we've talked about in earlier slides in the Azure environment, use other Azure products, and build your system end to end and schedule it using our platform. You can see the image on screen, and this was pulled just barely 5 minutes ago in real time from the NASA Aqua satellite through our entire platform chain. So very exciting.
Thank you, Rishi. This was amazing. Hope you liked the demo. We are happy to announce that Azure Orbital is now available for preview. Please reach out to us if you're interested in trying it out or have questions or feedback for us. So far, we have seen how Azure Orbital can be used for satellite operators to schedule contacts with orbital ground stations and downlink data from satellites and process in the cloud. Now let's change gears and take a look at the second scenario, which is Azure Orbital for global communications. In this scenario, satellite providers who provide global connectivity to their customers across a variety of industries like maritime, oil or gas, remote sites, and several others can use Azure Orbital to leverage Azure Global Backbone Network to augment their ground network. With Azure Orbital, satellite providers can co-locate ground stations with Azure data centers or in close proximity to the edge of our network. They can also interconnect their existing ground stations with our backbone network. This enables them to leverage global Azure backbone network to augment their ground network capacity. Azure Orbital Services delivers the traffic from orbital ground station to the satellite provider's virtual network in Azure. Using these Azure Orbital Services, a satellite provider can integrate or bundle other Azure services, for example, like security services like firewall, connectivity services like SD-WAN, and several others, along with their satellite connectivity to provide managed services to their customers in addition to satellite connectivity. While doing so, satellite providers can decide to deliver traffic and manage services to customers' on-premise network or even customers' virtual network in Azure. Or for that matter, transit to providers' network edge in another region while going through the Azure Global Backbone Network, or even leverage breakout at the edge of our network to provide internet services to their customers. Satellite providers can participate in the Azure Orbital MSP program to become a managed service provider for Azure. This enables them to use Azure Orbital and hence bundle and integrate other Azure services to provide managed services to their customers. The MSP model enables a satellite provider to achieve more by selling these services in addition to satellite capacity. SCS is one of the largest satellite connectivity providers in the space industry today. We are happy to share that SCS has selected Azure Orbital to augment their ground network needs for their next generation MEO constellation mPOWER. As part of this, we will be co-locating new dedicated ground stations in our data centers, in addition to interconnecting their existing ground stations with our global backbone network. SCS will leverage our global backbone network to route their traffic globally and use Azure Orbital services to provide multiple managed services built on top of our platform to their customers. These services will range from security services, SD-WAN, edge compute, and even include 5G mobility solutions to multiple other services. This will also help SCS with faster time to market with highly scalable ground station as a service by leveraging cloud-based virtualized modems provided as part of the Orbital platform in addition to the Azure Global Backbone Network. Let's have a quick recap. Azure Orbital, which is a cloud-based ground station as a service, is now available to you in preview. It unlocks significant opportunities across various industry verticals by enabling you to directly ingest data from space into Azure. It enables customers to address a wide number of scenarios that require processing of large volumes of data from space using several Azure services. With Azure Orbital Ground Station as a Service, satellite providers can optimize their ground network operations and provide managed services by direct interconnection to the Azure Global Backbone Network. For questions, feedback, and interest to participate in the preview, please contact msazureorbital@microsoft.com. Please feel free to also contact me at ashish.jain@microsoft.com. Thank you so much for your time. We look forward to you using Azure Orbital and providing your valuable and precious feedback to us. Thank you.